Okay. These two are switched around on yours?
Yeah.
So you have E and H. Okay, let's see if that works. Yep, that's the way it should be. Okay, so segment BC is the same as segment HF. Now you wouldn't even need the pictures, you could just look up here. BC are the middle two, FH are the middle two. Angle B is the second one, so angle F would be the same there. And CD would be the same as HE. So the only ones you don't need to label is a segment, because if it's two letters next to each other, it's assumed to be a segment, but it's not wrong if you put it there. Solving proportions. This one's an easy one. It's just cross, multiply, and divide. Is 18. This one, since there's more than one x, you gotta write an equation and solve it. 7 times x is 7x equals 6 times that. Since there's two things, you gotta take them both times 6. So that'd be 6x plus 12. So I'll get the x's together, just minus 6x, and you get your answer. X equals 12. Scale factor. All that is what's the ratio? So 8 to 16, you don't need to reduce it because it doesn't tell us to, but you could, 1/2. You could do 3.5 to 7, but you can't leave it like that because you can't have a decimal in a fraction. You could just move the decimal 2 spots and you'd get, or 1 spot, you'd get 35 over 70, which would be correct, but it does reduce to 1/2. What? Okay, when triangles are similar, you can write proportions to find sides, and corresponding angles are congruent. So on this one, the 2x, it's been flipped, and you'll have a better picture than this, but the 2x corresponds to the x. So then following that pattern, you'd say 4.5 corresponds to 2.25. This is one of those where it turned out to be many solutions, actually. I didn't set up a good one. Because when you solve it, there's 2 x's here. So you got to go that times that equals that times that. And you get the same thing on each side. You won't on your, you'll be able to solve it on the test. Well, it would be anything. X could be 0, 1, 2, 3, 4, 5. No matter what you put in, it would work. So on angles, they're just congruent. Since this is 40, so is that, because they're vertical. Now, remember what these colored triangles mean? Or filled in triangles? Remember, this means same length, which they're not. They're parallel. So alternate interior angles are congruent. So the x equals that, and you can figure out what that is because the angle's got to add up to 180. So you just take 180 minus this, minus that, and you get 70. So x would also be 70. Okay, again, writing proportions to find a missing side. You could do this a couple different ways. You could go x to 24, then follow the same pattern, 7 to 12. Or I could have went x to 7, 24 to 12.
I have to get these chairs.
Oh, okay. So you just cross, multiply, and divide. And you get 14. Here, F corresponds to 21. So then, F is the bottom of this triangle, so I'd put 6 to what? Right, the whole side, 21. You can't put 6 to 15 because 15 isn't the whole side of a triangle, it's just a partial. The bottom to the bottom equals the side to the side. So it'd be 21 times 6 divided by 21 would give you 6. Classifying triangles as right, acute, or obtuse. This is where you got to use the Pythagorean theorem. If a squared plus b squared equals c squared, it's right. If a squared plus b squared is less than c squared, you remember what that is? It's obtuse. It's the opposite of what you would think.
Are there 3 missing a sign? Looks like 9.41.
So you need that?
Yeah.
So then if a squared plus b squared is greater than c squared, it is acute. So remember, they're not always written in order. C is always the biggest one. So here, 8 squared plus 6 squared ends up, it does equal 10 squared. So this one is a right triangle. Here, 8 squared plus 9 squared, how does it compare to 15 squared? I think it's less. Yep, this is 145, this is 225. It's less, so it is obtuse. Then we get into the trigonometry stuff, sine, cosine, tangent. You gotta find x and y here. So, doesn't matter which one you find first. If I find x, x is the hypotenuse, 4 is opposite, so that's sine. Sine of 30 equals 4 over x.
So 4 divided by side.
Right, if x is on the bottom, you switch spots, so x equals 4 divided by the sine of 30. Remember, make sure your calculators are on degrees. So that'd be 8. So then what you could just do is use the Pythagorean theorem. Since it's a leg you're looking for, you would take the hypotenuse squared minus the leg squared and square root it. And it's 6.9. Now this one, if you would have noticed, does have a shortcut. Since this is 30, that means that's 60, so it's a 30, 60, 90. The hypotenuse is just double the short leg, and the long leg is just the short leg times the square root of 3. You could have just did that too.
So the sine, cosine, and tangent, what the sine is the hypotenuse and the opposite.
Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. So if you can remember the acronym, SOHCAHTOA. So for 14, there actually is a shortcut for 66-degree triangles. I don't remember what it is, but here you would have to use sine or cosine or tangent. So if I'm looking for x, 10 is adjacent, x is opposite, so I got to use tangent. Tangent of 66 equals x over 10. So to get x by itself, you just take it times 10. And you'd get 22.46, which would round to 22.5. Then to find y, you could just use the Pythagorean theorem. Since it's both legs, you would add them. 10 squared plus 22.5 squared, square rooted. is 24.6. You got 24.5.
Oh, no, 6.
Then solving the right triangle, it's doing the same thing we just did, except you gotta find the missing angles also. So here to find the missing side, you would just go 5 squared minus 3 squared, since it's a leg you're looking for, square root it, and you would get 4. Now to find an angle, say you want to find this one. You can use any one of these sides since that's not rounded, but all you just use cosine. 3 is adjacent, 5 is the hypotenuse. So if I say the cosine of A, I just called it A, equals 3/5. Remember what you do when you move the actual word over? It's the inverse. So A equals the cosine inverse of 3/5. That's when you got to use the key above the cosine key. So on these calculators, you'd have to go 3 divided by 5 equals, and then hit second function cosine. It's 53.1. On the other ones, you type it in just exactly how it is. So once you know one, you can find the other, because these two got to add up to 90, since that one's 90. So just take 90 minus 53.1 and you get 36.9. So for 16, to find the hypotenuse, it's the leg squared plus the leg squared, and then you square root it. And that should be 15. Yep. So, to find an angle, whichever one you want, I'll just find this one. I'll just use 9 and 12. 9 is opposite, 12 is adjacent, so that's tangent. Tangent of A equals opposite over adjacent. So to figure out A, you got to move the tangent over. It changes to tangent inverse of 9/12. And that's 36.9. So then just subtract that off of 90 to find that one. 53.1, they're the same one. It's just this one's bigger than that one. Okay, since these are both tangents, what do you know about that length and that length? They're equal. So it's just 2x plus 7 equals 5x minus 8. So you just got to solve it. Get the 2x out of there. Get the non-x there. It's a minus 8, so you add 8. Then divide by 3, and you get 5 equals x. So here, it's easiest if you just fill in all the angles right away. Since this is 55, so is that, because they're vertical. Here, this is half a circle, 180. So subtract these two off of 180, and that would be 35. And this is half a circle, so subtract that off of 180 to get that angle, 125. So, arc BAD. Start at B, go through A, and stop at D. It's 55, 125, and 55. It's 235 degrees. Arc DCB, this is an error. It should just be DB because it's less than a 180. Hey.
You have any rulers I could use?
Yes.
Excuse me.
We're not So this is just 90 and 35 is 125. So remember though, this one should just be called RDB, because if it's two letters, you take the shortest route to it. All right, then in these, here you gotta use inscribed angles and all that stuff. Right here it says this is 150 degrees. Since this angle is 20, how many degrees would that be? 40. Remember the inscribed is half of the arc, which means we can figure out what that is. 360 minus those two. $170. So, arc BC, well, we already figured it out, is 40. And arc AB is 170. For this one, we want angle 1. Remember what you do to figure out an outside angle? It's the arc minus the arc divided by 2. If it's an inside angle like that, it's the arc plus the arc divided by 2. So 80 minus 25, make sure you press equals before you divide by 2, is 27.5 degrees. And then arc DE. If you notice, since this chord equals that chord, that means these two arcs are equal. So if you take 360 and subtract these two off, you get 255 degrees. And since these are equal, you just divide that by 2. You get 127.5. Equation of a circle is x minus 8 squared plus y minus k squared equals r squared. I better put that up and leave that up there. So, this is the H, this is the K, and there's the R. So it'd be x minus a negative 4, would turn to plus 4, squared, plus y minus the K, squared, equals the radius squared. So all it is plugging it into the equation. Finding the value of x. This has 1, 2, 3, 4, 5, 6, 7. So you got to figure out how many degrees are in it. So remember, you take the number of sides minus 2 times 180. So that makes 900 degrees. Then you just got to subtract each of those off to figure out what x is. So on this one, to figure out this angle here, I'd first have to find this angle and then just subtract it off of 180 because together they make a 180. So this is 1, 2, 3, 4, 5 sides. So 5 minus 2 times 180 is 540. Did you figure out what it was? Is that what you said? No. So just subtract those off of 540. And this turns out to be 140, which means this angle would be 40 degrees. Not a very accurate picture, but that's okay. 132? Okay. Then the areas of the regular polygon. On a box, it's just going to be length times width on a square. So since these are all 90, this is 45. So again, you need to find this length. If you don't remember the special rules, you would use cosine. Cosine of 45 equals x over 8, and you'd solve for it, and then double it, and then the sides would be the same. Yeah, the shortcut is it's a 45. So the leg is just half of the hypotenuse times the square root of 2. Which means a whole side then would be double that, 8 square root of 2. So the area is length times width, which is 128. That one was the one that was on the test. On a hexagon, area is AP divided by 2. Apothem is from the center to an edge. The perimeter is the distance around. So this is a hexagon, which remember every angle is 120, which means this is 60. So again, if you don't know, remember the shortcuts, you can use sine and cosine to find A and this side here. But the shortcuts are, it's a 30, 60, 90. The leg, short leg is half of the hypotenuse. The long leg is the short leg times the square root of 3. I think this was the one that was on the test also. So, the area is the apothem times the perimeter. If this is 5, a whole side is 10, which remember in a hexagon, the radius and the sides will be the same. 10 times 6, 6 sides is 60. And then don't forget to divide by 2. And it's 259.8. Okay, then similar, find the ratio of large to small. So this is the largest, that's the small, of the perimeters and areas. This was on the last test too. The ratio is just 12 to 8. That's the scale factor. You don't need to reduce it, but you can. You can divide them both by 4 and you'd get 3/2. So remember, the perimeter is exactly the same as the scale factor. The area is always labeled squared. So all you do is square these. 3 squared is 9, 2 squared is 4. If you left it like this, that'd be fine. P is 12/8. Then the area would be 144 over 64. 12 squared, 8 squared. It reduces to the same. They're the same ratio. And then this is the last one, right? So, to find the length of AB, you first find the whole length, which is circumference. So it's pi times diameter. So we take pi times the radius is 7, so the diameter is 14. But we don't want all the way around, we just want 80 degrees out of the 360. So you just take it times 80 3/60ths. So 80 divided by 360 times pi times 14, 9.8 meters.